Personal finance practice problem using OneNote. Present value PV and future value FV mathematical formulas. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab, down in the 1113 Present Value and Future Value Mathematical Formulas tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations up top will also be in the text file, same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below, looking at those present value and future value calculations, this time focusing in on those calculations being done with formulas. First, we're going to give a quick recap of what we've done in the past so that we can see how these different calculations can tie together, or different ways that we can do the same calculations can tie together for the same problem. So just a recap of what we've seen in the past. Here's our problem up top. We're going to assume the value of property is increased at a rate per year of 7%. So usually when we're thinking about property, it could be land, it could be a home, it could be an investment, it could be stock, it could be a CD account, a savings account. It's going to go up in value. We're assuming it's going to go up by 7% a year. Then we're going to ask ourselves, how long before the property value doubles? How long before it doubles? Now, we can ask that question when using a calculation such as the rule of 72 without actually having the investment, just because that's, we're just saying any investment will double if you have the growth at the 7%. But to make it more practical to most people and concrete in our minds, it's often useful to then choose a number down here to pick so that if we choose $1,000 and we're trying to see when it's going to double, we're trying to see when that 1,000 will reach 2,000 if there's a rate of growth of the 7%. Now, first we applied the rule of 72, which is a nice shorthand, shortcut rule, but it's highly restrictive given the fact that we only have the answer of when something could double, not when it's going to, triple, or we can have other questions on growth that it can't really answer. So it's nice and useful for a simple calculation, but it's limited. So that would be the 72 divided by, in essence, the rate, but not in a percent or decimal format, the rate 7%. So basically divided by 7, we get about the 10.29. We also saw that calculation breaking out the interest year by year if we were actually to see the compounding in a table format, something quite useful, something that was more difficult to do in the past before having spreadsheet programs, but something that now is much easier to do. And I highly recommend taking a look at Google Sheets or Excel and putting together tables like this. It'll give you a better understanding of these kinds of problems. And then we took a look at the Excel format way to be calculating these as well. Most likely the most practical format to be using some kind of spreadsheet software such as Excel to do the functions and calculate these with functions, although even when using the functions, it's still a little bit kind of magical when we do it that way, because we basically get to these end result numbers and we don't really see the growth in the interest as we would with a running balance table here. We noted that we could do this with a future value calculation, present value formula or function, and the number of periods function, all different functions that are related, but they have the same unknown, so we can kind of think of it algebraically as that basically unknown. These different functions kind of reworking the same data in essence, and we had the same unknown, which was the number of periods. Okay, so now we're down here in the formula calculation. So just like we did up top, when we considered these two main formulas that we're thinking about, which are going to be the present value and the future value calculations, we don't usually remember the calculation, at least not mathematically, for the periods, the number of periods calculation. Instead, we kind of use these from an algebraic standpoint. So in other words, when you're thinking about present value and future value, you're usually going to be, if memorizing a formula, which you're not always going to do, because in practice, you're probably going to use the tables to basically figure this stuff out, and the tables and the Excel functions. But if you were to memorize a formula, you would typically memorize the present value and future value formula. So the present value formula looks like this. Present value equals the future value times, or you could say future value over as the numerator, the 1 plus r to the n. And 1, the rate, r is going to be the rate, which is 7%, n would be the number of periods. As we could see down here, future value, rate, number of periods. Now, if we were to do this algebraically here, what we're really looking for in our data is the number of periods, which in this case is n. So you might think in your mind, if you saw the answer to a problem like this in a book problem, they would probably solve for n and then make you think that you basically needed to memorize another formula for the number of periods. But that's not normally what people mostly do in their mind. They say, this fits into a present value calculation. Let me see if I can plug in all the numbers and see if I still have one unknown, that being n in this case, and then solve for n, given it's the only one unknown. So you could do that algebraically in this case, because we have the percent here, and we have the assumed investment amount. That's going to be the present value, our starting point. And we know the future value because our goal is to see how long it takes for this thing to double. That means that 1,000 needs to be converted to 2,000. So we could plug this in algebraically and just solve for the unknown, which I won't do completely mathematically here, but just so you could get an idea for it, you could take this equation, just plug in the numbers that we know. We have the 1,000 for the present value equals the 2,000 for the future value. That's our end point, 1,000 times 2 to double it. And then you could say over, because if you multiply this out, this is basically the numerator, or divide, and then 1 over the 1 plus the 0.07, the 7%, r, in other words, is 7%, to the power of n. N then would be the unknown, and then you basically solve for the unknown. Notice as we do that, if you solve for the unknown, that's kind of similar to our equations up top, where we then had another equation up here that was for a function called the NPER that we kind of looked at when we looked at the Excel functions. Now, I'm not going to do the algebra. You could do the algebra format that way. What I'm going to do is basically build our kind of table here as you might build it if you were kind of taking your equation and put it into a table format similar to how you might see like a tax equation type of format, which is practical in practice just to learn how to build up a table. When you're looking at small formulas, it can be useful to use this kind of format, and it also gives us a better comprehension of how to use this feature of goal seek to kind of take our algebraic concept, which is solving for one unknown. If I only have one unknown, I should be able to solve for that one unknown, but also using that goal seek concept, doing it by trial and error instead of reworking the algebraic equation, because when you apply computers to this, the computer can do that very easily. So it's a useful skill to have when you're working in a spreadsheet like Excel, because it's a very easy thing to basically do. So what I'm going to do is take this formula up top, present value equals future value times 1 over the 1 plus r, or I'm going to consider it as if the future value is over 1 plus r, because it basically is the same thing, future value in the numerator. And we're going to put that into our table. I'm not going to rework it solving for n. I'm just going to plug in an unknown in our table for n, and then consider how we use kind of trial and error to figure that out. So it looks something like this. If I see an equation like this and I want to make a table of it, what I would imagine doing is that if I see the future value on top, is I would like the outer column of the table to be the numerator and the denominator, whereas in the end of this calculation, I'm simply going to divide out the outer column. Any other added detail that I need to do that in a more complex setting like the denominator down here, I'm going to break out into a more detailed format in the inner columns. So this is how you might structure a table like this. Financial statements are kind of structured in a similar way, so you could get this grouping down. It's quite useful to look at. It's quite useful to be able to see other tables and not roll your eyes at them because you don't understand kind of the formatting of them. So we're going to take the future value. That's going to be the outer column. That's the numerator. That's the 2,000. So that's the 2,000 because that's where we're going to end up, which is doubling the 1,000 investment. And then we're going to take the denominator here, which is the 1 plus r to the n. I'm going to write that out and put a colon next to it. That's going to indicate that everything underneath this is going to be basically getting to this bottom line number. So that's going to be indicated with a colon. I'm going to pull it into the inside to also indicate that. And I'm going to indent the data here whenever I have data over here to indent. So I'm going to start off with 1. I'm not going to call that anything on the name. I'm just going to say 1. And then the rate was 7%. So 1 plus R, which is 7%, which you could write at 0.07, or you can write the 7% here. 1 plus the 7% is going to be 1 plus R, or 107. Notice I put another subtotal in our calculation. So we got the 1 plus R there, and then I'm going to take that to the power of n. Obviously, the 1 plus 7 is, you could think of it as 100%, or 1 plus 0.07, which is 1.07, or 107%. So let's make this a little bit larger. And then we'll take that to the power of n. So that's going to be this point. We're taking it to the power of n. That n power is the unknown. We don't really know what that is. So we have the answer here at the 10.424, but the fact that it's yellow is indicating the fact that we don't really know what that is. Now, if this was an Excel sheet, I would put that in the outside over here in some cell and say, hey, this is the unknown function. I'm going to make it yellow to indicate that we're going to use our trial and error to kind of back into that unknown function. And then we're going to say that this 107 to the power of 10.24 would be 2. I'll get back to that calculation in a second. And then we're going to have the division of the 2,000 divided, because we got the numerator and the denominator fair value over this down here. So the 2,000 divided by 2 would equal then the 1,000. So once again, the thing is here we plugged in the answer of the 10.24. Notice if we didn't know the answer and we were just to guess something like 5 here or something like that, then we'd get to the wrong answer. And if we had the ability to just use brute force, to just keep on changing this number to figure out what this n number would be, then we can clearly do that. It would be difficult to do by hand, but obviously if we have an Excel sheet to do that, then Excel can do that quite quickly. And there's a tool in Excel called goalseek that's quite useful to do that kind of format. So in doing that, the reason I want to point this out is that basically you're kind of doing the same concept of algebra in that way, meaning if I have one unknown, I can solve for that one unknown, but instead of doing that this way by solving it and reworking the formula for n, I'm simply going to use trial and error. And if I have a computer to do that, that allows me to set up a nice spreadsheet in the format that I know how to do, and then use the trial and error format to back into this number. That's quite useful here. It's also quite useful when you get into more complex systems with functions where you cannot as easily rework an equation algebraically. Okay, so if I was to do that and I was to goal seek, I would ask Excel here, please change this cell until the end result, this result, the present value, gets to be what I know it should be, which is 1,000, and it would then change the result to that 10.24, which we can then, so we're going to pull up the calculator. We're going to take this to the power of 10.24. I'm going to make the calculator a little bit larger. Make sure you got a calculator that can take it to the power of the 10.24. We think may need a scientific calculator or something like that. So I'm going to go to the scientific calculator, the 10.24. Hold on a second. It's not 10 point. We're going to take the 1.07, which is 107%, and then I'm going to take that to the power of, which is x to the y, gives us that little caret up top. Then I'm going to put in the 10.24, and then that should give us our answer, which is about 2, not exact, because this number, again, is kind of rounded over here. Okay, so then we're going to take then, let's bring it back to our normal calculator now. Normal calculator. Then we're going to take our 2,000 divided by 2, and that would give us to our 1,000. Once again, this number is basically rounded, so it's more digits than the 10.24, but that's approximately what we have there. Now, we could do the same thing, and this is to kind of point out the relationship between these formulas. We could also use the future value formula and then find out the same, basically, period that we wouldn't know. So the future value formula is future value equals the present value times 1 plus r, the rate, to n, which is the number of periods. Now, again, you could plug this in algebraically and solve for n, future value being where we're going to end up, 1,000 times 2, because we're going to double it, 2,000 equals the 1,000, which is the present value, the current point that we would be in, times 1 plus r, which is 0.07 or 7%, to the power of n being the unknown. Now that we have one unknown, you can work that algebraically. Now, once again, I'm going to plug this future value formula into an Excel worksheet, not solving for n, but simply then solving or figuring out what the unknown is. Imagining we use a goal seek or a trial and error method, which we can once again do easily with a computer. So I want these two components to be on the outside of my table now when I make up my table. And so here's how we're going to have it. We're going to have the present value on the outside, and then we're going to have the 1 plus the rate to the n periods, colon, indicating that I'm going to do this on the inner column now. There's the 1, and then the rate is the 7%. So here's the rate at the 7%. This is indented now, indicating that this is a subcategory. That's then the answer is going to be in the outer column. So then that's going to be the 1 plus the 7%, or the 107%, which if sawn in a calculator would look something like this. 1 plus 0.07, which would be 1.07 or 107%. Then we're going to take that to the power of the 10.24, that 10.24 being the unknown, which we would, if we didn't know what the answer was, we would put something in it so it wouldn't be 0, something like 5 or something like that to start off with, and then we can ask Excel to basically adjust it. And that would give us this to the power of 10.24. That would give us this amount, or this side, and then we can multiply the 2 out. The 1,000 times 2 is going to give us then the 2,000, Now, this has the answer in it. This is the 10.24 that we wouldn't know if we didn't know it. We can choose some number here like 5, calculate for it, and then you can imagine basically just using trial and error, adjusting this number randomly instead of adjusting the equation algebraically to solve for n until you get to the end result that you need the end result to be. So on an equation like this where you can solve it algebraically, that might seem like, why would I do that if I can solve it algebraically? But if you have a table like this, that can be a useful skill. And if you're using functions instead of algebraic equations, you can also do this kind of method as well, and that allows you to set up your table and basically back in to the certain numbers. So then I would ask Excel, would you please set this cell to whatever it needs to be to get to the end result where we know it should be, which is of course the future value of 2,000, double the starting point. So then if I was to calculate this, we need a calculator that can take it to the power of the 10.24 again. So I'm going to go back to my scientific calculator. We're going to be scientific about this. Let's be empirical. So we're going to take the 1.07 and then we're going to take that to the XY, which is the caret, and then the 10.24. So there we got about 2 because this number is rounded, the 10.24. I'm trying to stop saying again in case I've been bugging you by saying again a lot. I noticed that, so I'm trying to stop. Bear with me. Don't get mad about it. So just a tick. Okay, so then we got the 1,000 divided by 2, or times 2, and that would give us then our 2,000. So hopefully that gives us an idea of the relationship between present value and the future value calculations and the different methods you can use to calculate them. We're going to continue on next time because this isn't the last method. We can also use tables. So next time we'll move on to the tables to get to a similar result. There's a tendency, I always had a tendency when I was learning this stuff to say, hey, this is the way I like doing it. I'm just going to memorize the way because that works, and I'm just going to do that. And you could do that for yourself, but just realize that if you're trying to communicate with other people or understand what they're doing and they're doing it different, that doesn't work. And often also, if you really want to know the material, then what you really want to do is understand how to look at things from different angles. So it doesn't really work to try to fix, I do it my way and this is the only way I'm going to learn it and I'm going to save brain space or something like that. No, the point is to integrate, as many different angles as you can so you understand a fuller picture of it and so you can communicate it to other people. So, and also, of course, if you go to a test or something like that, they might take away your calculator or take away Excel or whatnot, make you use tables and stuff.